Hello everyone, my name is Sheng-Chieh Lai and I'm from National Taiwan University and my advisor is Dr. Guo. Today I'm going to show you my research on wood identification using cross-section image and convolution neural networks. Wood is one of the primary products of forests and plays an essential role in human society. Wood could be used in multiple purposes such as heating, furniture building, and more based on its diverse properties. And because of its diverse properties, the price of the wood between species vary considerably. Thus, to understand the usage and the values of land, it is crucial to identify them first. In conventional method, the experts could identify the wood from macroscopic or microscopic aspects, and from a macro perspective, the expert could use naked eye to distinguish the wood by its visual features, such as color and annual ring, and use auxiliary features such as smells and texture. And from a micro perspective, they can use a microscope to observe the types and arrangement of cells. And however, this way share the same problems. They are time-consuming and subjective. Furthermore, the experts are aging listed. Labor shortage is also a problem. So to solve the problem, the objective of the research is to develop a deep learning model to identify wood species. And the picture below is the system pipeline. Okay, so let me introduce more about wood. Wood could be roughly divided into hardwood and conifer, and they belong to different divisions in biology and could be easily distinguished by their leaves or seeds. And comes to the wood itself. Hardwood have little holes on the cross-section area, which is a little hole on the image, and while conifer don't, which makes it easier to classify these two categories. So with the acknowledgement of hardwood and conifer, I will first introduce the hardwood species in my research, then the conifer species. And these are the targets of hardwood in my research. And there are 34 hardwood species here. These are the targets of conifer in my research. There are 28 conifer species here. Totally, 62 wood species are consisted in the research. The wood specimens were collected from a herbarium at Taiwan Forest Research Institute. And the specimens were dehydrated and made into blocks. The top and the bottom surface are the cross-section area. And to obtain a clear surface of cross-section, a razor was used to trim the surface by freehand. After the pre-processing, the wood image was collected by using a flatbed scanner whose resolution is set to 1200 dpi. Then the cross-section image will be cropped from the scanned images and cut into multiple square sub-images whose size are 224 pixels by 224 pixels. And the actual size are around 0.5 centimeters by 0.5 centimeters. And because the color of wood will be different due to the environment and growth, so to avoid misclassification because of this situation and simplify the calculation, the sub-image were converted to grayscale. This is the bar chart of sub-image number for every species. The dataset had roughly 116,000 sub-images in total, and 90% of the data is for training, and 10% for testing. And to increase the diversity of model, I applied data augmentation to the data. The CNN model I chose is Inception ResNet v2. This is the architecture of the model. The model has three spatial modules, which is Inception A, B, and C. These three modules combine the advantage of InceptionNet and ResNet. They use multiple kernels with different sizes to increase the width of the model, and use residual learning to deepen the model. This enables the model to learn more features without compromising accuracy. This is the training details of the model. So the model achieved an accuracy of 98%, and the plot at right is the confusion matrix of the model. We might not see any useful information in this plot at first glance. However, if I put these two lines, we can see that the misclassification mostly occurs among hardwood species themselves or conifer species themselves. I also visualize the features extracted from the last layer before classification layer using TSNE. It is a technique that can embed high-dimensional data into a low-dimensional space. And most groups are widely spaced, which means the model could extract the features well. And some species might slightly separate it into several groups. It comes from the higher individual difference of the wood species. And also, and here, we can see that the warm color species, the hardwood species, and the cool color species, the conifer species, can be easily divided by circling a red dotted line, which shows the same result in confusion matrix. Then the model mostly misclassify the hardwood species themselves or conifer species themselves. So the model would misclassify some species. I think there are some issues causing the problem. The first one is these species have similar patterns after being converted to grayscale. This is the hardwood example. And this is the conifer example. We can see that the grayscale image of this pair have similar features, which leads to misclassification. And the second one is imbalanced data with similar features, which caused the model couldn't classify the species with fewer data correctly. This is the hardwood example. And this is the conifer example. We can see that the model most classify the species with fewer data to the species with more data. And the third one is image size. These two species are hardwood and conifer respectively. The left one is the hardwood and the right one is a conifer. We can see that they don't look similar and they should have little chance to misclassify. However, in some circumstances, the sub-image of the right species would only consist the light part, like this, and which made it look like other species and cause the misclassification. And the last one is some flaws in the image, including some big defects on wood blocks, like knots, and the parts that were not well trimmed. We can see that the sub-image would almost lose the features that could be used for identification. And to sum up, the model achieve an accuracy of 98.35%, and the model could successfully extract the features. And in the future, I plan to screen the data before training and acquire more image data to balance the data sets. Thanks for your listening.
Thank you, presentation. Education.
Thank you for the presentation. It's very interesting and also very refreshing. How I like it very much how you took the time to check and classify examples. That's very informative. And I think in the confusion matrix and also later in the SME, you said that the misclassification occurred within the either conifers or hardwood species, right?
Yes.
So probably, do you think it could be an idea to first classify into conifer or hardwood, and then make a decision and then train two separate classifiers for only one or the other kind of wood separately?
And this is a very good suggestion. And yeah, I think your suggestion is very good, and it could be converted. It could be used two models to classify hardwood and conifer respectively. And however, we should, if we do that, we need to identify this is hardwood or conifer first. Then
Right. So you would need
maybe two
different
stage,
models.
right?
Yes.
And I don't know how to, I don't know what is the inference time that needed, maybe.
What do you mean, sorry?
You need to identify the hardware first. Maybe you need to take some time.
Well, but you have the species already, so you could only train one classifier to say hardwood, yes, no, and then depending on that, then train the second classifier only for one species and have two different correlation matrices in the end. Well, that was one idea. And can I have you have time?
Yeah, we have time.
All right. Could you show the TSNA? I was wondering if the color has some meaning, or it's only the hardwood and conifer.
What?
The color. The color has like a meaning itself?
The color only just
It's only
separate the hardwood and conifer. Color didn't mean anything.
all right. Okay. Thank you.
Thank you.
Have you other question?
Thank you for the presentation. Very good idea. Could you explain what the issue exactly was with the RGB images? And did you train models with RGB images and train them with the grayscale and realize the grayscale was better, or were they just scrapping the data?
Yeah, the wood might absorb different nutrition and makes the wood looks different. Just like the white rose, if you put it in a blue water, they will become blue, right? I want to avoid that situation. If you train a model with many different colors, I don't think the model could learn well.
Okay, thank you.
Thank you.
Yeah. If you have any question, please ask him personally. Yeah. Thank you.